Welcome back students. So let's start our chemistry class. Our fifth method is dissolution followed by evaporation or crystallization. I am hoping that you have a certain idea about evaporation and crystallization, right? Because you have studied it in previous class. We will see it over here also. So this method is useful for a solid mixture of which one component is soluble in a chosen solvent but the other is not. Example, a mixture containing salt or sugar which are soluble in water that we know, and sand, chalk or sawdust which are insoluble in water. Second, sulfur soluble in carbon disulfide and iron fillings which are insoluble in carbon disulfide. So what we are doing is stir a salt sand mixture in water. In this, you imagine that when you mix the salt and sand mixture, the salt will get mixed in the water, but the sand will not, and the sand will settle down. That we have studied in sedimentation, right? So, what we will do, we will filter the mixture. So, the previous method which we had used, filtration, is taking place over here also. So, the salt passes into the filtrate because the salt is mixed with water. The filter paper cannot separate salt from water. Please remember that. Alright. But the sand is separated. And the sand remains as residue on the filter paper. The residue is washed with warm water to make the sand free of salt. The filtrate, along with the washings, is slowly heated in a dish when the water evaporates and the salt is left behind. So after filtering, what we are doing is we take the filtrate, that is the liquid which we have obtained after filtration, and we start heating it. When we start heating it, the water will evaporate and what we will get behind is salt. A purer sample of the salt can be obtained by crystallization from the filtrate. The filtrate is heated to obtain a concentrated solution, which is a solution containing a smaller proportion of the solvent than usual. When the concentrated solution is left to cool slowly, the white crystals of the salt separate. Remember that a purer solid is obtained from a solution by crystallization rather than by evaporation to dryness. Crystallization sets in better and faster if the concentrated solution is seeded with the small crystal of the pure solid. For seeding, you may simply have to add the solid to the concentrated solution while cooling. So what is happening is, they are saying that it does not happen that you evaporate it totally and you dry it off, the filtrate that you are having. You have to leave a concentrated solution so that their crystals can be formed. The salt that we see are small crystals of salt. They are saying a method which is they are telling about is seeding. What is happening in this is, when you have evaporated and you have reached a concentrated solution, you put a small crystal of the pure solid of which you want to form the crystals. Like in this case, we have to form the crystals of salt. So we will add a small crystal of salt. For seeding, you may simply have to add the solid to the concentrated solution while cooling. So you have learnt in the previous class how crystals of candy can be obtained from a concentrated solution of sugar. Here you can try to obtain the crystals of copper sulfate pentahydrate, also called blue vitriol. We will see how. So here they have given us an experiment which we can perform in the lab whenever the school reopens. Let's now see what they are saying. Prepare a concentrated solution of copper sulfate in a beaker by dissolving as much of the salt as possible. Heat the mixture occasionally to dissolve more and more salt. Filter and evaporate the solution in a basin till a crust is observed at the surface of the liquid. Stop heating and allow the solution to cool. Beautiful blue crystals of copper sulfate pentahydrate will appear slowly, which will grow in size with time. For your reference, I have attached the image on the right side. You can see that also. So similarly, sulfur can be separated from iron fillings by stirring the mixture with carbon disulfide. the example which we have seen in the starting, right? So the sulfur comes out with the solvent, iron is filtered out, and the filtrate gives sulfur on evaporation or crystallization. So our next method is distillation. By distillation, we can separate a solid liquid mixture which is homogeneous, example a solution of salt in water, or heterogeneous, example a sand water or a chalk water mixture. So by distillation, we can separate both kinds of mixture, homogeneous as well as heterogeneous. The apparatus is set up as shown in figure 3.9. You can see it in your book. The mixture is boiled in a distillation flask. The vapors coming out condense while passing through a Lebesgue condenser, in which they are cooled by the water circulating in outer jacket. The pure liquid, example water, is collected in a receiver. The solid, soluble or insoluble, remains in the distillation flask. So what they are saying is that by using the method of distillation, firstly you can separate both kinds of mixture, that is homogeneous as well as heterogeneous. How does this apparatus work, which is figure 3.9 in your book? They are saying that when we start boiling the liquid that we are having, its vapors start coming out. We have seen, right, evaporation takes place. The vapors coming out condense while passing through a Lebesgue condenser. See in the image this. This is the Lebesgue condenser. What is happening over here is the vapors that are formed, they condense over here. How? They are including water over here and taking it out over here. So water is sent from here and taken out from here, and the vapors that are going through this, they condense. That is, they turn into a liquid because they are vapors, and they turn into liquid. The pure liquid, example water, is collected in a receiver. Whatever liquid that we are having, we take an example of water over here. So we get water over here in the receiver. The solid, soluble like salt or insoluble, remains in the distillation flask. Whatever solid is mixed, it will remain over here in the distillation flask. Alright. Next is fractional distillation. You should remember that fractional distillation, this separation method, is used when there are two liquids which are having the difference between their boiling points by 20 degrees Celsius or more. That is, the difference between their boiling point should be 20 degrees Celsius or more, otherwise it can't be separated. So, the liquid mixture is boiled in the distillation flask, as it is happening in the previous also, right? Fitted with the fractionating column and a Lebesgue condenser. So, what is the difference over here? Here a fractionating column is attached. This one. This is the fractionating column which they are talking about. So, and a Lebesgue condenser, which we had seen earlier also. The mixed vapors enter the fractionating column, where the vapors of the higher boiling, that is less volatile, liquid condense and trickle back into the distillation flask. The vapors of the lower boiling, that is more volatile liquid, however, pass into the Lebesgue condenser, where they condense. The liquid is collected in the receiver. So as we have seen earlier in the starting, that they were saying in this we are having two liquids and they are having difference between boiling points of 20 degrees Celsius or more. So the two liquids, when we put them in a distillation flask, right, they start boiling. Firstly, a particular temperature is achieved in that distillation flask, and it means that the lower boiling point is achieved first, right? If we start heating something, firstly 80 degrees Celsius will reach, or 100 degree, of course 80 degrees Celsius. So the liquid that is boiling, which has the boiling point of 80 degrees Celsius, it will start boiling at that point and it will evaporate. Alright, and then it will be taken out and it will go through the Lebesgue condenser and we can collect it in the receiver. After the liquid, which is having lower boiling point, has been removed and it is taken out in the receiver, then the second process, that is the process of boiling of the second liquid. Maybe it is of 100 degrees Celsius, then it will start, because the first liquid has evaporated totally, right? Now the second liquid, which is having 100 degrees Celsius boiling point, it will start evaporating, and we can take it out in a second receiver. Alright, the temperature of the boiling mixture remains constant till the lower boiling liquid distills completely. Then the temperature again rises till the higher boiling point liquid starts distilling. The receiver is quickly changed, because otherwise it will also come in the same receiver. So the receiver is changed to collect the higher boiling liquid. The liquids obtained by boiling a mixture at different temperatures are called fractions, and the method of fractional distillation is also called fractionation. By this method, what we can separate is these things: benzene, boiling point 80 degrees Celsius, from toluene, which is having boiling point 110 degrees Celsius, and same is with other examples. So just go through them. We will see the next method in our next video.